In this video, we're going to learn about aqueous solutions and pH. So the first thing you need to know about acidity and basicity with water is that water auto-ionizes. That means that if you have a pure sample of water, then it will react with itself, and it will separate into H3O plus and OH minus. Here you can see there are two water molecules, and one transfers an H plus over to the other, and that leaves you with H3O plus and OH minus. Now, this is an equilibrium process, and you'll see that the left arrow is longer than the right arrow. This is intentional because definitely water as a molecule is favorable relative to the ionized forms H3O plus and OH minus. However, this equilibrium does exist. And at 25 degrees Celsius, the equilibrium constant for this process is equal to 1.0 times 10 to the negative 14th. Again, indicating that there really isn't a lot of the products, but there is some. Now, an acidic solution is any solution where the H3O plus concentration is greater than the concentration of OH minus, and basic solutions have an OH minus concentration greater than H3O plus concentration. If, of course, you throw a bunch of HCl in water, well, the HCl is going to dissociate, as you're fully aware, and you will end up with more H3O plus, right? More H3O plus because a lot of that water has picked up an H plus from the HCl to form H3O plus. And of course, there's a chloride negative on its own. A basic solution, of course, if you had, say, some sodium hydroxide is actually just throwing hydroxide ions into the solution. And that, of course, will increase the amount of OH minus relative to the amount of H3O plus. In a pure sample of water, of course, the concentration of H3O plus and OH minus has to be equal because for a water molecule to pick up a hydrogen plus, well, another water molecule has to lose an hydrogen plus. Sorry. um, so that is that. Now, in the case of strong acids, the H3O plus concentration rises, of course, and all strong acids, we just assume that they dissociate 100%. And because that auto-ionization of about 10 to the negative seventh molar is almost nothing, it's negligible compared to any noticeable concentration of a strong acid, we can just say that if you have a strong acid that's, say, 0.5 molar in concentration, well then, because the water doesn't really contribute anything noticeable in the first place, and because the HCl dissociates 100%, well, our zero point 0.5 molar HCl gives us a concentration of H3O plus that is equal to that 0.5 molar. Now, pH is something that relates to concentration of H3O plus, and it's something that you may have heard of a long time ago. Now we're going to get into the real scientific and mathematical definitions of what pH is. pH is the negative logarithm of the concentration of H3O plus. So we know that a high concentration of H3O plus will give a high acidity. And so in that case, the negative log of a high concentration of H3O plus would actually be low. It would be a low number. And so a low pH means that you have an acidic solution. A high pH would mean that you have a basic solution. We'll get into the calculations in the next video. pOH is also something that can be used to measure basicity. And pOH is the negative log of the concentration of hydroxide ions, meaning that a low pOH would be a basic solution and a high pOH would be an acidic solution. Now, at 25 degrees Celsius, we know that the concentration of H3O plus times the concentration of OH minus in any aqueous solution is going to be equal to 10 to the negative 14th power. Um, in the case of pH and pOH, well, because we're talking about the negative logarithms, it really is the negative sum of the two exponents. So what we end up with is pH plus pOH is equal to 14. Um, and that will always hold true. So these two formulas are useful to you if you ever are going to do calculations of pH and pOH, or concentration of H3O plus and OH minus. And again, this is something that we'll cover more in depth in the next video. I do want to point out before we get into that, all the nitty gritty of the math, that by definition, a change of 1 pH unit means a concentration change by a factor of 10. So if you have a 10 molar concentration of HCl, well, we know that for a strong acid like HCl, whatever the concentration of the acid is also equal to the concentration of the H3O plus. So its concentration is 10 molar. Now the pH is actually going to be equal to -1. And that's because, well, -1 is that exponent that pertains to the logarithm of 10, or sorry, the negative logarithm of 10. A 1 molar solution of HCl, so we are now diluting by a factor of 10. We are going from a 10 molar to a 1 molar solution. It has a concentration of H3O plus, that's the same, also 1 molar, and its pH is 0 because 10 to the 0 power is equal to 1. And a pH, sorry, a 0.1 molar solution of HCl has a concentration of 0.1 molar and a pH of 1. And this next one I'll fill in as 2. What we can see here is that going from, say, a 10 molar solution of HCl to a 0.1 molar, we're talking about a dilution of a factor of 100. But that actually is only a pH difference of 2 because 10 to the second power is 100. So I just wanted to point out, we tend to think in terms not logarithmically. Just as humans, we tend not to think in logarithms. And it can be really tricky. You feel almost like, it isn't a big shift when you change the pH by 1. It's actually changing concentration by a factor of 10. So it's very, very much noticeable. And that is all for this video. Next one, we'll deal with calculations of pH and pOH and concentration of H3O plus and OH minus. I hope this video has been helpful. Please feel free to leave any questions or comments in the comment section below. Thanks for watching.